I'm going to start with a segment and stick it there. Now I'm going to grab my circle tool and I'm putting a circle through there. What is AB in relation to that circle? Radius, fantastic. And I draw another circle here. What is AB in relation to that circle? The radius, okay. So there we have our image. Now I'm going to get hopefully that point of intersection there to there and there to there. I'm just going to test that I've actually got that point of intersection by moving that. Yep, okay. Now, who can tell me what type of triangle that is? Isosceles? Anyone else? Equilateral. How do you know it's an equilateral? How can you prove that? Aha. So what you're saying there, if we just grab that and pop it into here, okay, you're saying that this circle here, that's the radius, but that's also the radius of that circle. And this circle here, that's the radius, and that's also the radius of that circle. So that means that these three are all the same, and therefore that is an equilateral triangle. Okay, so if that's an equilateral triangle, what's this angle here? What's that angle? 60. Okay, and then this one? 60, and then this one 60. Okay, very nice. So we can see that kind of proof there. Beautiful. Now I want to pop, actually I might put, no, that's okay. I put that down there and I want to try and get that intersection there, and I'll just check that it is the right place. Yep. Okay, who can tell me now what these angles are? So I'm asking, what is, if we look at this triangle here, what can you tell me? What can you tell me about this angle here? 90. How can you prove that? Imagine if I joined down there and joined down there, you could put a mirror line through there, yeah? And down here, that also a mirror line, beautifully symmetrical, so that's actually all your 90s. Okay, now let's go back to this. What is the angle here? This one. That's 30, because that one's also 30 and it's symmetrical. Okay, so 60 and 30 is 90, so that's another proof that that would be 90. Okay, if I join that way, what would this angle be? 120. Well done. And how did you know? Angles on a straight line. Okay. If I go back to my little drawing, and this time I'm going to get lines instead of points, so I'm going to extend that, extend that, extend that, extend that, extend that. Okay. And back here. So can you tell me some more angles? What's this one here? 60. What's this one? What's this one? What's that one? And this one? 1, 2, 3, 4, 5, 6. Fantastic. What about this line here and that line here? What can you tell me about them? They're parallel. Well spotted. Now, I want to show you how this builds up, if you like. If I get more circles and I go like that and like that and like that and like that and like that, yeah, and more of these. So okay, there's all sorts of beautiful math in there. One shape I want to draw your attention to within that, I'm going to go from there, yeah, it's beautiful flowers, there to there to there to there to there. Okay, so that one there, can anyone tell me what that shape is? It's a hexagon, and hopefully some of you can see that a hexagon tessellates for a very good reason. What's that angle? If I go like that, and like that, can you tell me what this triangle, whoops, we could have fun. That triangle there is what sort of a triangle? Equilateral. So there's 1, 2, 3, 4, 5, 6 equilateral triangles. So that was 120, yep. Yeah, and then 120, and then 120, yeah. Okay. So in and amongst all of that, we actually did have hexagons tessellating. So quite a complicated kind of a pattern. Hopefully that helps you see the, oops, there we go, see the hexagons a bit better. Confusing? Yeah, there we go. Oops. Should be able to move that one. So weird.